Hello everyone, this is Brian Orlasan Cordova and welcome back to another calculus class. So for our topic for today is tests for convergence and divergence of infinite series. So number one, we have the geometric series test. So in previous video, natakal na natin siya. So given a geometric series in the form a plus ar squared plus so on and so forth. So this is equal to the summation of a times r raised to n minus 1, where n is from 1 to infinity. If the absolute value of r is less than 1, then r raised to n approaches 0 as n approaches infinity, and the series converges to the sum a over 1 minus r. If the absolute value of r is greater than or equal to 1, then the absolute value of r raised to n approaches infinity. So the series diverges. For example, determine whether the series 1 minus 1/3 plus 1 over 9 minus then up to plus negative 1/3 raised to n minus 1, then so on and so forth, converges or not. So we want to determine whether it is a convergent or not. If so, to what limiting sum? So as a solution, so first identify muna natin yung a, which is equal to 1, so the initial term, and yung common ratio, which is r, so it is equal to negative 1/3. Then since yung absolute value no r is absolute value of negative 1/3 is actually positive 1/3 and it is less than 1, so then the series converges to a sum and it is a over 1 minus r. So substitute natin yung values. So 1 over 1 minus negative 1/3 is equal to 1 over 4 over 3. So this will become 1 plus 1/3. This is equal to the reciprocal of the denominator since 1 lang yung nasa ibabaw. It is equal to 3 over 4. So the series converges to the sum of 3/4. Now the second test is the nth term test for divergent series. So as a theorem, if the summation of a sub n, where n is from 1 to infinity, converges, then a sub n approaches 0. That is, the limit of a sub n as n approaches to infinity is equal to 0. So yung ating nth term, ang limit niya would be 0. It converges. So the nth term test for divergence is that the summation of a sub n diverges if the limit of a sub n as n approaches infinity fails to exist, or the limit does not exist or not equal to 0. Example. So the summation or the series of n raised to 2, where n is from 1 to infinity. So it diverges because as n increases, yung n squared is lalong mag-i-increase. So its limit is positive infinity. So the limit does not exist. Another example, we have the series n plus 1 over n as n starts from 1 to infinity. So it diverges because n plus 1 over n, ang limit niya is 1. And it is not equal to 0. Even though it exists, it is not equal to 0. So it diverges. Example number 3. So we have the series of negative 1 raised to n plus 1. It diverges because the limit of the a sub n, which is negative 1 raised to n plus 1, as n approaches to infinity, does not exist because it is an alternating series of negative 1 and 1. Number 4, we have the series of negative n over 2n plus 5. It diverges because the limit of negative n over 2n plus 5 is equal to negative 1/2, and it is not equal to 0. So according to the nth term test for divergence, if the limit does not exist or not equal to 0, it diverges. So combining series, so there's a theorem if the series of a sub n is equal to a and the series of b sub n is equal to b are convergent series, so parehas na convergent yung series of a and b, then number 1, sum rule. So the series of the sum, so pinag-add natin yung similar terms ng bawat series, it is equal to the series of a sub n plus series of b sub n. So just like in the sequence, so meron tayong sum rule and it is equal to a plus b where yun yung sum ng series of both a and b. So difference rule, so ganun lang din. We have the summation of difference is equal to the difference of summations. It is equal to difference of sums. Constant multiple rule, ganun din dun sa sequences. The summation of k times a sub n is equal to k times the summation of a sub n, which is equal to k times a for any number k. So there are corollaries from this. Every non-zero constant multiple of a divergent series diverges. Meaning, nagda-diverge pa rin sila. Nag-multiply ka lang ng constant. Number 2, if the series of a sub n converges and the series of b sub n diverges, then the series of the sum of a sub n and b sub n and the series of the difference of a sub n and b sub n are both diverging. So both diverges. Examples. Find the sum. Given the series of 3 raised to n minus 1 over 6 raised to n minus 1 as n starts from 1 to infinity, let's simplify this by dividing the numerator by the denominator. So 3 raised to n minus 1 over 6 raised to n minus 1 is actually 1 over 2 raised to n minus 1, then minus 1 over 6 raised to n minus 1. So this is a summation of the difference. So we can simply get the summation of each terms. So we have the sum of 1 over 2 raised to n minus 1 minus the sum of 1 over 6 raised to n minus 1. Now, both series is a geometric series with a is equal to 1 and yung r is 1/2 and 1 over 6 respectively. So we have the sum of the series 1 over 1 minus 1/2 minus yung sum ng second term, second summation, we have 1 over 1 minus 1 over 6. Simplifying, we have 2 minus 6 over 5, which is equal to 4 over 5. So this is the sum of the given series. Number 2, find the sum of the series 4 over 2 raised to n as n starts from 0 to infinity. This is equal to 4, which is a constant multiple. So nilabas na natin. And we have the series of 1 over 2 raised to n na lang. Then this is actually a geometric series with a is equal to 1 and r is equal to 1/2. So we have a sum of 4 times 1 over 1 minus 1/2. So this is equal to, so simplifying yung nasa loob ng parenthesis, we have 2. 4 times 2 is equal to 8. So that is the sum of the given summation. So reindexing, that is adding and deleting terms. So this is part where we manipulate the index of the given summation and changing the form of the a sub n. So if the summation of a sub n, where n starts from 1 to infinity, converges, then the summation of a sub n, where n starts from k up to infinity, converges for any k greater than 1. And the summation of a sub n, as n starts from 1 to infinity, is equal to a sub 1 plus a sub 2 plus so on and so forth, plus a sub k minus 1 plus the summation of a sub n, where n starts from k up to infinity. So this is a continuation of the summation. So we are getting the first k sub 1 terms plus the summation of the series with the terms na start ka ng k. So conversely, if the series of a sub n starting from k to infinity converges for any k greater than 1, then the series of a sub n starting from 1 to infinity converges also. So we can reindex any series without altering its convergence as long as we preserve the order of its terms. So that is series of a sub n from 1 to infinity is equal to the series of a sub n minus h as n starts from 1 plus h to infinity is equal to the same series of terms. And also, if we change the index by subtracting h, yung index dun sa a sub n is mag-a-add naman tayo. Same series. So we can add or subtract a certain value to the index, or we can start from any point as long as we compensate dun sa a sub n, so that summand of the given summation. So examples, the summation of 1 over 5 raised to n, starting from 1 to infinity, is equal to 1/5 plus 1 over 25 plus 1 over 125 plus the summation of 1 over 5 raised to n. Then we start ka na from 4 because nakuha mo na yung first 3 terms and up to infinity. Now this implies that the summation of 1 over 5 raised to n starting from 4 up to infinity is equal to summation of 1 over 5 raised to n starting from 1 to infinity minus the 3 terms. So we can write the geometric series, the summation of 1 over 2 raised to n minus 1 starting from 1 to infinity as 1 plus 1/2 plus 1/4 plus so on and so forth, as the summation of 1 over raised to 2n starting from 0 up to infinity, or 1 over 2 raised to n minus 5, but you start n from 5 up to infinity, or 1 over 2 raised to n plus 4, you start your n from -4 up to infinity. Non-decreasing partial sums. Consider the harmonic series, the summation of 1 over n, and it starts from 1 to infinity. Even if a sub n approaches 0, so yung nth term, ang limit niya as n increases approaches to 0, for the nth term test, the series diverges. Why? Because there is no upper bound for this partial sum. Okay? Because when you still keep adding terms, kahit na yung nth term niya is approaching 0, you still add values to the partial sum. So 1 plus 1/2, and yung following 2 terms is actually greater than 2/4 or greater than 1/2. So mag-add ka pa rin ng 1/2. So you still keep adding more than the previous added terms. So this one also, this group of terms is also greater than 4 over 8, which is 1/2. So this group is still larger than 1/2, and also this one. Even though yung n term mo ay papaliit, yung ina-add mong terms ay papalaki pa rin. So yung partial sum keeps getting larger. The sum of the group terms are larger than 1/2. Adding the succeeding terms of the group of terms will increase the partial sums indefinitely. Thus the series diverges. Integral test. There's a theorem. Let a sub n be a sequence of positive terms. Suppose that the n term a sub n is equal to the function f of n, where f is a continuous positive decreasing function of x for all x greater than or equal to n, where n is a positive integer. So then the series, the summation of a sub n, where n starts from big N to positive infinity, and the integral of f of x dx from big N to infinity, both converges or both diverges. So as a proof ng theorem ng integral test, the assumption is that f is a decreasing function. F of n is equal to a sub n for every values of n. So kung decreasing function siya, so there is a function, yung graph niya is pababa as n increases or yung value ng x. So yung kinukuha natin dito is yung a sub n natin is actually areas of the rectangles, the series of areas. Areas a sub 1, a sub 2, up to a sub n enclosed more area than under the curve y is equal to f of x. From x is equal to 1 to x is equal to n plus 1, because kung makikita natin, lumagpas yung area na sakop ng rectangles ng a sub n's dun sa given curve na y is equal to f of x. So mas malaki yung masasakop from 1 to n plus 1. So since the integral is actually the area under the curve of f of x, from 1 to n plus 1 is less than or equal dun sa sum of a sub n's. So from a sub 1 plus a sub 2, so summation of the areas. Now let's consider the given function and we start yung area from 0 to 1 like this. Kung titignan naman natin, the areas below enclosed less area than under the curve of y is equal to f of x from x is equal to 1 to x is equal to n. So, dito hindi na natin i-consider yung first area, the a sub 1. So, disregarding a sub 1. So, yung sum ng areas from a sub 2, so from 1 up to n naman, is less than or equal dun sa area under the curve, which is the integral of f of x dx from 1 to n. So, if we include a sub 1, that is a sub 1 plus a sub 2 up to a sub n is less than or equal a sub 1 plus the integral of f of x dx from 1 to n. So, combining the two inequalities, so the integral of f of x dx from 1 to n plus 1 is less than or equal to the sum of the areas from a sub 1 to a sub n. And this is less than or equal to a sub 1 plus the integral of f of x dx from 1 to n. Now, from this given inequality, if integral is infinite, it is divergent. Or if finite, they are convergent. So for infinite, if the integral is infinite, since it is smaller or equal to the given series, meaning yung larger sa kanya would be also infinite. And if the right side of the inequality, a sub 1 plus the integral is finite, then the series is also finite. Since the right side is bounded, so that means the series which is smaller or less than that is also bounded. So it is finite and convergent. Example, determine the convergence or divergence of the series. Number 1, the summation of n times e raised to negative n raised to 2, where n starts from 1 to infinity. F of x is equal to x times e raised to x squared. So we change n into x and put that into a function. So solution, applying the integral test. So the integral of the given function, so we bring down the negative exponents into a denominator. So we have x over e raised to x squared dx. This is actually equal to 1/2 the integral of du over e raised to u. So algebraic substitution. So u is equal to x squared and du is equal to 2x dx. Now getting the integral of this, we have the limit as b approaches to infinity of negative 1/2 e raised to negative u, where u is from 1 to b. So substituting the limits, so we have the limit of negative 1 over 2e raised to b plus 1 over 2e as b approaches to infinity. So evaluating the limit, this is approaches to infinity. Now this whole term approaches 0. So what remains is the second term, so 1 over 2e. Since the integral converges to 1 over 2e, the series also converges. Example number 2, the summation of 1 over 2 raised to ln of n, where n starts from 1 to infinity. So the function is 1 over 2 raised to ln of x. So let's get the integral of the f of x. So we have dx over 2 raised to ln of x from 1 to infinity. This is equal to the integral of e raised to u du over 2 raised to u, where u is equal to ln of x and x is equal to e raised to u. Thus, dx is equal to e raised to u du. Simplifying that, we have the integral of e over 2 quantity raised to u du. Now, evaluating the integral, so this is limit as b approaches to infinity of 1 over ln of e over 2 times e over 2 quantity raised to b minus 1. And as b approaches to infinity, this is also approaches to infinity. So thus, the whole term approaches infinity. Since the integral diverges, the series also diverges. So we can use the integral test in error estimation. Let R be the remainder and S be the sum of the series and S sub n the partial sum of the series. So we can estimate the sum S by adding the first n terms to get the partial sum S sub n. But we need to get how far off the partial sum S sub n is from the total sum S. Suppose that a series A sub n is convergent by integral test, and we want to estimate the size of the remainder R sub n. So we can use the integral of f of x dx from n plus 1 to infinity is less than or equal to R sub n. And yung R sub n is actually given the total sum S, we subtract the partial sum that we can get to get the remainder. So the remainder is equal to A sub n plus 1. So we start from that since naka-indicate dito. And so on and so forth up to infinity, which could be less than or equal to the integral of f of x dx from n to positive infinity. This is given from the integral test. So bounds for the remainder in the integral test. Suppose the sequence a sub k of positive terms with a sub k is equal to f of k, where f is a continuous positive decreasing function of x for all x greater than or equal to n, and that the summation of a sub n converges to the total sum s, then the remainder R sub n is equal to total sum s minus partial sum s sub n satisfies the given inequality. So the remainder would be sandwiched between these integrals which came from the integral test. So adding the partial sums to both sides, we have partial sum plus the integral of f of x dx from n plus 1 to infinity. Then R sub n plus the partial sum is actually the total sum. Then less than or equal to s sub n plus the integral of f of x dx from n to infinity. So it is useful for estimating the error in approximating the sum of the convergent series by the integral test. So example, estimate the sum of the series of the summation of 1 over n squared. Let's have a partial sum from n is equal to 10. So as a solution, we have the integral of 1 over x squared. So ang f of x natin is 1 over x squared dx from n to infinity. Evaluating the integral, we have negative 1 over x. Then taking its limit, since x is from n to b, and as b approaches infinity. So substituting the limits, we have the limit of negative 1 over b plus 1 over n. As b approaches to infinity, so the first term approaches to 0. So this is equal to 1 over n. So we can now use the given inequality. Now substitute s sub n is the partial sum up to n is equal to 10 plus 1 over 11 since it starts from n plus 1. So the integral of f of x dx from n plus 1 is 1 over 11. Less than or equal to s, less than or equal to s sub n is s10 plus 1 over 10 since it is from n. So the integral of f of x dx from n up to infinity is 1 over 10, given that n is equal to 10. Okay, next, s sub 10 is equal to 1 plus 1/4 plus 1 over 9 plus so on until you have 1 over 100. Since your a sub n is 1 over n squared, in n is equal to 10, so we have 1 over 10 squared as the 10th term. So this is approximately 1.54977. So if we add 1 over 11 to that s sub 10, we have 1.64068. And if we add 1 over 10 dun sa s sub 10, so plus 1 over 10 dito, we have 1.649777. So we have two boundaries for the total sum. Approximating the midpoint for approximating the total sum. So the summation of 1 over n squared from 1 to infinity is approximately 1.6452. So kuhanin lang natin yung midpoint ng dalawang boundaries na yun. So number 4, the p-series test. So the P series is in the form summation of 1 over n raised to P, where n starts from 1 to infinity, as P is a real constant. It converges if P is greater than 1 and diverges if P is less than or equal to 1. So if P is greater than 1, by integral test, the integral of 1 over x raised to P dx from 1 to infinity is equal to integral of x raised to negative P dx. By evaluating the integral, we have the limit as b approaches to infinity of x raised to negative p plus 1 over negative p plus 1, and x is from 1 to b. Since this is actually equal to negative of p minus 1, so this is equal to 1 over 1 minus p is from the denominator. So 1 over the denominator, positive 1 minus p. We substitute b to x. So b raised to negative of p minus 1. So since negative yon, ibababa natin sa denominator. We have b raised to p minus 1. Then minus 1, since x is equal to 1, yung lower limit. So raised to any power, so it is still 1. And b raised to p minus 1 approaches to infinity as b approaches to infinity because p minus 1 is greater than 0. Since p is greater than 1, this one approaches to 0 since ang denominator niya ay mag-a-approach sa infinity. So we have 1 over p minus 1. Since positive yung p minus 1 is still a positive number, and it will not be equal to 0 since p is greater than 1. The integral is finite, then the series converges. If p is between 0 and 1, then 1 minus p is greater than 0. So itong numerator na to, negative p plus 1 would be positive. So hindi natin kailangang ilalagay sa denominator. So this will become 1 over 1 minus p, then the limit of b raised to 1 minus p since positive na yon, minus 1. So this is actually, as b approaches to infinity, this term also approaches to infinity. Now it diverges. If p is less than or equal to 0 naman, the series diverges by the nth-term test. Because if negative yung power ng denominator, it will become a numerator. And as we add a whole number to the series diverges by the nth-term test. If p is equal to 1, then we have the divergent harmonic series. Thus, we only have convergence for p greater than 1, but divergence for all other values of p. So number 5, the comparison test. So there's a theorem. Let the summation of a sub n, summation of c sub n, and summation of d sub n be series with non-negative terms. Suppose that for some integer big N, d sub n is less than or equal to a sub n and less than or equal to c sub n. So yung mga n term nila is in this form for all values of n greater than big N. So A, if the summation of c sub n converges, then the series of a sub n also converges because c sub n will become bounded. And if d sub n diverges, since mawawala ng limit itong d sub n, it will become unbounded, then a sub n also diverges. So yung mas malaki sa kanya would be also infinite and divergent. For illustration, we have c sub n natin is convergent approaching to 0. Therefore, yung a sub n natin also bounded to go to 0. So the partial sum of a sub n are bounded above by capital M, which is the summation, which is the sum of c sub n. And the partial sum of a sub n in B are not bounded above because yung mas maliit sa kanya na summation of d sub n would be unbounded na rin. Thus, it diverges if the lesser series diverges already. Okay. Examples. The series of summation of 5 over 5n minus 1 from where n starts from 1 to infinity. So it diverges because its nth term 5 over 5n minus 1 is equal to 1 over n minus 1 over 5 is greater than 1 over n. So we can verify that it is larger because yung denominator is lesser. Mas maliit yung denominator, mas malaki yung value ng buong fraction. It is greater than the nth term of the divergent harmonic series. So 1 over n is the nth term of the harmonic series, which is divergent. So since this is larger than the divergent harmonic series, so divergent na rin siya. Then number 2, the series of the summation of 1 over n factorial, where n starts from 0 to infinity. It's just like that. So it converges because its terms are all positive and less than or equal to the corresponding terms of 1 plus the summation of 1 over 2 raised to n. So this is equal to 1 plus yung geometric series na 1 plus 1 half plus 1 over 2 raised to 2, so on. So we have 1 plus the sum of the geometric series, 1 over 1 minus 1 half is equal to 1 plus 1 over 1 minus 1 half is 1 half. So we have reciprocal dito, 1 plus 2. So we have equivalent to 3. Now since yung given series natin is less than dito sa series na in-introduce natin, which is convergent to 3, so the given smaller series is bounded by this. So it is the upper bound only of the given series 1 over n factorial.